Hello, today we are gonna do our team project, Learning Through Recreation. The team members are Yu and Junhee Meng.
Okay, so part A, knowledge understanding. Number 1, determine whether each question is true or false and circle the correct answer. So this question, each mark is worth 1 mark. Choosing the correct answer in true or false questions can be considered that students are understanding the definition of the concept accurately.
A. The derivative is used for finding the average rate of change of a function. The derivative is used for finding the instantaneous rate of change of a function, so it is false. B. The exponential form of a function represents the growth after time x. This is the right statement, so it is true. C. Quadrant bearing is the measurement between 0 degree and 90 degrees south or north of the east-west line. The quadrant bearing is the measurement between 0 degree and 90 degree west or east of the north-south line, so this is a false statement. Number 2, write the differentiation rules that will be used when the functions below are differentiated. Describe each rules with general terms. Do not make functions below two derivative forms. Labeling the name of each differentiation rule is charged as 0.5 marks, and describing that rule with general terms is marked another 0.5 points. Knowing the name of differentiation rules and when they are used is a very integral ability through the whole unit, so this question can verify it.
Fourth number A is f of x equal to x squared, and question B is g of x equals bracket 3x plus 2 bracket close square. So for question A is power rule has to be used, and for the general term, if the function is formed like this equal, then f prime of x equal nx to the n minus 1. For the question B, chain rule is used. If the function is formed like f of x equal g of p of x, then f prime of x equal g prime of p of x times p prime x. Question 3. Explain the vector below using two measurement methods with the name of them. So this question, each answer will be charged as 1 mark. Knowing how to explain the vector using both methods is essential for next steps. As this question provides a Cartesian plane, it matches with the section of thinking and inquire.
The answer for this question by using true bearing is the magnitude is 20 meters at a bearing of 240 degrees. And by using quadrant bearing, the magnitude is 20 meters at a quadrant bearing of south 60 degree to west. Number 4, differentiate with respect to x, 2 marks. Differentiating the sinusoidal functions, 1 mark for differentiating. This question is designed to check if you understand and can use the differentiation rules of sinusoidal properly.
So question A, the first step is derivative y equal to x to the 4th plus 5 sine x cubic. So outside derivative first and inside. So I'm going to dy over dx equal 8x cubic times sine x cubic plus 2x to the 4 plus 5 times cos x cubic times 3x square. So x square bracket 8x sine x cubic plus 6x to the 4 cos x cubic plus 15 cos x cubic. And question B is also the first step is derivatives. So if I do tangent for derivative is secant square, so dy by dx equal secant square 7x cubic times 21x square. So if I do the final answer is 21x square times secant square 7x cubic. So number 5, find the critical numbers for the function. For this question, using the first derivative is 1 mark and find the critical numbers for 0.5 mark. This question checks the understanding of first derivatives and define critical numbers, values that become 0.
To find the critical number of the function f of x, I have to do the first derivative. If I differentiate f of x, f prime of x equals 8x plus 8. The critical number is the x value when f prime of x is 0, so it is stated as below. 0 equals 8x plus x. Therefore, x equals -1. Therefore, the critical number is -1. Number 6, determine the average rate of change from x equals 2 to x equals 5 for a function 1.5 marks. Find the average rate of change for 1 mark. This question checks the understanding of average rate of change and how to find it by using the slope formula.
Okay, so y equal x cubic, so when x is 2, y equal 2 cubic, so it's gonna be 8. So and when is x equal 5, so y equal 5 cubics, it's gonna be 125. And using the slope formulas, that's y2 minus y1 over x2 minus x1. So we know y2 is 125 and y1 is 8, so 125 minus 8 over, and x2 is 5, so 5 minus 2 equals 39. So therefore the average rate of change is 39. And part D, application questions. So number 7, 100 milligram of iodine 131 has spread into a pond and decays to 84 milligram after 2 days. The amount of iodine 131 remaining after t days is given by n of t equal initial n e to the negative lambda t. So the question A, find the disintegration constant lambda for iodine 131. So this question will verify if the solver can specify the initial value and where to put variables which are given in the question. Also, it can check the solver has the ability to use natural log logar log logiterations for finding the exponent. It requires the basic concept of exponential functions, so two marks is proper.
The initial value is 100, and when t equals 2, the amount of iodine 131 becomes 84 milligram. By using them, I can state the function like this: n of 2 equals 84 equals 100 e to the e negative lambda equals 100 e to the negative 2 lambda, and divide both sides by 100. 84 divided by 100 equals 100 divided by 100 e to the negative 2 lambda, so that the question becomes 0.84 equals e to the negative 2 lambda. Put ln in both sides, then it'll be like this. Ln 0.84 equals ln e to the negative 2 lambda. The ln e equals 1, so ln 0.84 equals negative 2 lambda. So not lambda equals ln 0.84 divided by negative 2, so that is about 0.087. Number B, question B, find the half-life of iodine 131, 3 marks. It checks if the solver knows what half-life means and can put the half of the initial value correctly to n of t. Also, it can verify that the solver can use the natural logarithm for finding the exponent.
So we know the n of t equal 100 e to the negative 0.087t. So half of the initial value is 100 divides 2, so we can find 50. So 50 equal 100 e to the negative 0.087t. So when I divide it, 50 divides 100 equal 100 divide 100 e to the negative 0.087t. So 0.5 equal e to the negative 0.087t. Using on both sides ln, so ln 0.5 equal ln e to the negative 0.087t. So that's become negative 0.087t, and t equal ln 0.5 divides negative 0.087. That is about 8 days. So therefore, the half-life of iodine 131 is about 8 days. So question C, write the exponential function again with the base of 1/2. So this question, this asks if the solver can change the base of the exponential function which is used for half-life. Values needed are found from question A and question B, so it deserves 1 mark.
The original function is n of t equals 100 e to the negative 0.087t. If I change the base of it by 1/2, then it becomes n of t equals 100 1 over 2 to the t over h. The half-life, which was found from B, is 8 days, so n of 8 should be 50. If I put 8 into n of t, then n of 8 equals 50 equals 100 1 over 2 8 over h. Therefore h becomes 8. Therefore the function will be n of t equals 100 1 over 2 to the t over 8. Question D. How fast will the sample decay after 6 days? 2 marks. Question C requires the ability to find out how fast represents the derivative of a function. Also, the differentiation of exponential functions is needed. It has the key concepts of Unit 5, so 2 marks should be given.
Okay, so first write the equation of n of t. So n of t equal 100 e to the negative 0.087t. So when I do first derivatives, is n prime of t equal 100 e to the negative 0.087t times ln e times negative 0.087. So when I put the 6 into the prime equations, so n prime of 6 equal 100 e to the negative 0.0876 times ln e times negative 0.087 is about negative 5.2. So therefore the sample will decay at a rate of 5.2 milligram per day after 6 days. So this is the end of our group projects. Thanks for listening.